Tension. So tension is just simply talking about something that's moving in the y direction. So if a force is pulling upward, it's tension. It can be a rope, it can be somebody actually pulling on it, we still call it tension. And if it's an elevator, tension is equal to the force normal. That's the normal force pushing upward, right? So remember that the tension pulls the elevator, and the normal force pushes on the person to move with the elevator. So, and always unspoken is that Fg is always there. So let's look at some examples here. So first example, I have a simple diagram in which I'm looking at my force vectors, not moving in the x direction, so I'm only worried about the y direction. And my tension, the magnitude, the length of my tension vector is clearly greater than my weight vector. Sum of my individual forces acting in the direction of motion is T plus Fg is equal to ma. So remember that Fg is pointing downward, so the number value will have a negative associated with it. T is greater than Fg, so it wins out, so acceleration will be positive. So let's run through an example. I have an elevator and I have 600 newtons as the tension. I have the mass of the elevator, but I'm missing the weight. But I can calculate that because Fg is always equal to mg. So that's going to be equal to 20 times 10, because we round, or 200 newtons. And this will be a negative 200 newtons because it's pointing in the downward direction. So the sum of my individual forces is going to be equal to 600 plus negative 200, which will be equal to 20a. Or 400 is equal to 20a, a is equal to 20 meters per second squared. At this point, I can put my units of acceleration in. Moving awfully quickly, but that's okay. Here's an example of the elevator, another elevator with the same tension, but now my weight is much more, my Fg, so my Fg is winning out, so my acceleration will be negative. So again, I have my tension listed as 600 newtons, the same 600 newtons, but now the weight of my object is 80 kilograms instead of 20. So I always have to put in my Fg, and that's going to be equal to mg, which is 80 times negative 10, or negative 800 newtons. So I can now do my math. Sum of my individual forces will be equal to 600 plus negative 800 is equal to 80a. Or negative 200 is equal to 80a. A is equal to, cross these out, 820 over 8, or negative 2.5 meters per second squared. So either I'm going to be falling down and speeding up, or I'm going to be slowing down. Either way, what's happening is that my tension is not winning out. This is one of the reasons why elevators have weight limits, so that you don't have to worry about a situation in which the elevator is trying to move up, but the weight is causing it to move down, and indeed accelerate at that point, which would not be a good thing. Now, we can have a situation in which I have equal forces, right? That's what we call static equilibrium. So I could ask the question, I have a 25 kilogram box. What would the tension need to be in order for me to safely hang the box? So I know my Fg. Fg is always known if I know my mass, 25 times negative 10 mg, or negative 250 newtons. So if I want my box to just stand still, or my picture to stand still, then I need my forces to be balanced. I don't want my picture moving, so my A needs to equal 0. So the sum of my individual forces, that's my tension plus my Fg, has to equal 0, because for ma, if A is equal to 0, everything will be equal to 0. So this tells me tension plus negative 250 is equal to 0. What would happen? That's when tension is equal to 250 newtons in the positive direction.